mathematicians. In this video, we're going to talk about simplifying radicals. First of all, I just want to remind you, mathematicians, we love to simplify things. We simplify fractions, we simplify expressions, lots of things we simplify. Simplifying creates equivalent things, equivalent fractions, equivalent expressions. And when things are equivalent, they're really the same value, but just viewed from a different perspective. Now, radicals are another type of mathematical thing that we can simplify. So in this video, we're going to walk through how do we know when a radical is fully simplified. And for this, we're going to see there are three things that we need to check for to determine whether a radical is fully simplified. Now, thing number one is that there can be no perfect squares under the radical sign. And this connects to that activity we did a couple classes ago about visualizing square roots and taking a square and partitioning it into smaller squares. So think about that when we talk about this. So a radical is fully simplified when first thing is no perfect squares under the radical. So no perfect square, I should say no perfect square factors. No perfect square factors under that radical sign. You can think of them as perfect squares, think of them as square numbers. Let's do a quick little example. If I have the square root of 18, I know that's the same as the square root of 9 times 2. That idea, and there we have 9 as the square, the perfect square, the square number. Think about that visual of how we can partition that square. Using one of our properties, this is the same as the square root of 9 times the square root of 2, or 3 times the square root of 2. So here is the simplified version of the square root of 18. No perfect square factors under the radical. The next thing is pretty simple, and that's the fact that we can have no fraction under the radical. So for example, if I had the square root of 3 over 16, can't have that fraction under there. What I can do is, again, using one of those patterns we talked about in the last video, this is the same as the square root of 3 over the square root of 16. Nice thing, once we've done this now, we can go and simplify each the numerator and the denominator. Square root of 3, there are no perfect square factors, but square root of 16, I know that's a perfect square itself. So that's the same as the square root of 3 over 4. Awesome. Now the last one is a little bit tricky, and it's the fact that we can't have any radicals in the denominator of a fraction. So let's look at that. So we'll say no radicals in the denominator. Let's look at an example for this. We have 4 over the square root of 3. Notice we have a radical in the denominator of our fraction. So we have a really interesting way to solve this, to not have that radical in the denominator. We need it to be an equivalent fraction, which means we have to multiply the numerator and the denominator by the same thing. What we're going to multiply by is whatever this radical is. So I'm going to multiply the numerator and the denominator by the square root of 3. That means the numerator becomes 4 times the square root of 3. Now the denominator, if you have a square root of 3 times the square root of 3, that's the same as the square root of 3 squared, which leaves us with just 3. Let's get back to my pen. So by multiplying a radical, a square root by a square root, it will undo that square root and we're left with just what was being square rooted. Does that make sense? If not, make sure you ask me and we can talk about it some more. This technique is so helpful, it actually has a name, and it's called rationalizing the denominator. Rationalizing the denominator. Rationalizing. Or rationalize, we'll just write that. And that's it. So mathematicians, we know a radical is fully simplified if there are no perfect square factors under the radical, if there's no fractions under the radical, and there's no radicals in the denominator. In the next video, what we're going to do is walk through 3 examples, and we'll give you a chance to try for yourself. Can you use these some of these techniques to simplify a radical yourself? All right, see you soon.